This is 9.5, solving quadratic equations using the quadratic formula, part 2. So we have something called the discriminant, which is the expression b squared minus 4ac in the quadratic formula. That is the part that is inside the square root in the quadratic formula. And we use the discriminant to determine the number of real solutions that an equation is going to have. So if the discriminant is greater than 0, it will have a graph that looks like this, and so it will have 2 real solutions and 2 x-intercepts. The x-intercepts are the solutions. If it is equal to 0, it will have 1 real solution and 1 x-intercept. And if it is less than 0, it will have no real solutions and no x-intercept. So if it is positive, if it's equal to 0, and if it's negative. So we're going to determine the number of solutions and solve. For x squared plus 8x minus 3 equals 0, looking at the discriminant, so we're looking at what is b squared minus 4ac. We get 8 squared minus 4 times 1 times negative 3, which gives 76. And 76 is greater than 0, so it has 2 solutions. Now when we solve, plugging in our a, b, and c into the quadratic formula and reducing, we're going to get our 2 solutions of 0.36 and negative 8.36. For x squared plus 4x minus 4 equals 0, looking at the discriminant, we get 4 squared minus 4 times negative 1 times negative 4, which reduces to 16 minus 16, which is 0. So this has 1 real solution. And then we plug it into the quadratic formula, and we're going to get negative 4 plus or minus the square root of 0 over negative 2. Because we found the discriminant, this b squared minus 4ac, is 0. So that is negative 4 plus 0, negative 4 minus 0, which is negative 4, over negative 2, which is 2. So here we only get 1 solution. And we've done a few different ways on how to solve quadratic equations, and there's some advantages and disadvantages to each. So the first one we did was factoring. Factoring is great if the equation is straightforward when it's easily factored, but some equations are not factorable at all. Next we did graphing. And graphing is great when you can easily see the number of solutions you're going to have, or if approximating is a sufficient answer. If you need exact, this is not the way to go. Using square roots is great, because if we have something that can be written as x squared equals some number, then all we have to do is take the square root of each side. But it can only be used in that case. If you have an x squared term and an x term, you cannot use solving by square roots. And then we have the quadratic formula. And this is great because it can be used for any quadratic equation and gives exact solutions. The downside is that it is time consuming. Now we're going to look at a few different quadratics and explain which way is going to be the best way to solve it. So if I have 9x squared minus 5 equals 4, I'm going to solve this one using square roots because I can rewrite it as 9x squared equals 9, which is x squared equals 1. If I have 2x squared minus 13x minus 24 equals 0, this is not easily factorable, so the quadratic formula is going to be the best way. And if I have x squared plus 8x plus 12, this is easily factorable, because 2 numbers that multiply to 12 but add to 8 are 6 and 2. So factoring is going to be the fastest and probably easiest way to go about solving that one.